Welcome to part 2 of the Putting It All Together video lesson. We're going to take a more complicated example now that involves a combination of u-substitutions, chain rule, and within the context of a definite integral. Okay, so first of all, we've clearly got two functions that are multiplied by each other. The second one is also cubed, and then within that cubing function there's this 2 plus 3 cosine 10t. So you have this inner function, and then you have an outer function, and then you have a function outside of that. This looks like it might be a good candidate for a u substitution, with u being the innermost function. And again, the process for doing a definite integral is to first solve the indefinite integral, you drop the plus c, and in this case we are going to need both a u substitution and within the u substitution we're going to have to use the chain rule. But after we're done with all of that, we'll be able to take the indefinite integral. Step 2 of this process is going to be to evaluate that indefinite integral at the two boundary values, upper boundary, lower boundary, subtract the 2. Okay, let's start trying to tackle this. Innermost function becomes u. Take the derivative of both sides. Alright, so we've got a little bit more complicated derivative here because it's got more than one term, and then it's got this 3, and then it's got the cosine, and then you have an inner function. So let's take a methodical approach. We got the plus sign here, and that means we have to distribute the derivative across these two terms. Alright, derivative of a constant is 0. And in this second term of the derivative, we can at least take the constant and move it outside of the derivative symbol. Alright, now, we know how to take the derivative of cosine of t, but we've got cosine of 10t. And since we've got an inner function and an outer function, that means we use the chain rule. So, this is going to be, I'm going to drop this 0 over here. Derivative of cosine is negative sine. And then derivative of the inner function, that is 10t, is just 10 to the 0 times t to the 0th power. Alright, clean this stuff up a bit. And we're done taking the derivative. So we use the chain rule. And we are almost done with our u substitution. What we need to do is isolate dt, multiply both sides by dt, divide both sides by the quantity 30 times sine of 10t. So that will give us that. Okay, now we need to take this quantity, not including the cubed part, which is equal to u, and throw the u into that part, and take all of this stuff and put it in where we see the dt. And leave this term, this sine 10t, leave that alone, or else you're going to need it to cancel out with this sine 10t. When you're done with all of that substitution, what you end up with is, let's see. By the way, notice that now that I'm switching to u as my independent variable, I have to either abstract the boundary values as just a or b, or transform them. I find it easier to just replace them with variables as placeholders. Alright, this is a big ol' ugly function, but a lot of stuff cancels out really quickly. So, this whole part here cancels out with this whole part here. As long as t is not equal to 0, we're good here, and at none of these two points does t equal 0. Does sine of 10t equal 0. Okay, so what we're left with is alright, well that looks pretty darn simple. This is just a power rule application. Now remember, when you're integrating with the power rule, the power increases by 1 and then the exponent also becomes the denominator. Okay, do a little bit of algebra real quickly. Back substitute our original function for u. Let's see, I already used green. How about blue? Okay, so take our function for u, and that goes into there. And now that we're back to t as being our independent variable, we can take our original boundary values and throw them in here. And there you go. Okay, now all we have to do is actually evaluate these. So, let's check to see where we are. We've done the u substitution. We dropped the plus c. We are completely done with the indefinite integral because there's no more integration signs. Now all we're left with is this last step here. Alright, let's do this whole step in blue. Alright, this looks really complicated, but it'll simplify really soon. All I did was take the pi over 10, and that's our upper boundary, so that's how I get this part that's between my two index fingers right now, and then we subtract this whole function with the pi over 20 substituted into it, so that's the portion between my index fingers now. Alright, so 10 over 10, that cancels out, and 10 over 20, that's the same thing as 1/2. So what we get is negative 1 over 120 times the quantity 2 plus 3 times the cosine of pi. All of this stuff in the square brackets is raised to the 4th power, plus the two negative signs become a plus sign. 1 over 120 times the quantity 2 plus 3 cosine of the quantity pi divided by 2. All of that raised to the 4th power. Okay, cosine of pi over 2. Well, if you remember your cosine function, that's 2 pi radians, that's pi, and then this here is pi over 2. So, cosine of pi over 2 is, fortunately, 0. So what we're left with on this side is plus 1 over 120 times 2 to the 4th power. Alright, let's see what we get over here. Okay, so cosine of pi is negative 1. Negative 1 times 3 is negative 3. Negative 3 plus 2 is negative 1. Negative 1 to the 4th power is 1. So this is going to be 1 over 120. Okay, so let's see, 2 to the 4th power, that's, let's see, 2 squared is going to be 4. 4 times 4 is 16. Okay, so this is going to be 15 over 120, which is divide top and bottom by 5, so that's going to be 3 over, let's see, 24, is that right? Yeah, 24, okay, divide top and bottom by 3 again, so that's 1/8. Alright, so, took a whole page, but that's what you end up with. Alright, there will be one more example in the next problem.